Hello everyone, welcome to Codecrafters Lab. So today we are going to see the next problem from the string section, that is isomorphic string. Given two strings s and t, determine if they are isomorphic. Two strings s and t are isomorphic if the characters in s can be replaced to get the t. Okay, and what are the rules for replacement? All occurrences of character must be replaced with another character while preserving the order of characters. So order should be preserved. No two characters may map to the same character, but the character may map to itself. So it's like a one-way mapping. So that's why no two characters can map to the same character, but a character can map to itself. Okay. Then example, egg and add. Okay, so why it's true, why it's isomorphic? So E can be mapped to A, then G can be mapped to this second D, and then again G, it can also be mapped to the D. It was already mapped to D, so that's why it's isomorphic. Let's see the another example. So paper and tighter, whether it is true or not. So P can be mapped to T, right? Then A can be mapped to I. Yes, it can, because there is no already mapping for it. Then again P occurred. So P is already mapped to T. So here the character should be T. So yes, it is T. Then again E can be mapped to L. Yes, it can map because there is no mapping for E. Then again R can be mapped to E. Yes, R can be mapped to E because E is already mapped but R is not mapped. So that's why R can be mapped to E. So that's why it is a true isomorphic. Then S equal to apple and T equal to BBNM. Is it possible to is these two strings are isomorphic or not? Okay, can we convert T to S? So A can be mapped to B. Yes. P can be again mapped to B. No, this can't happen because that is not true. We can't map like a like a different characters to a single character, right? So this is not true. Here it is, the case was different. E is mapped to L, then R is mapped to E, so that is possible, but you can't map A to B and P to B, right? Then again S equal to ABC and T equal to TTN. Is it possible? A is mapped to T, then again B is mapped to T, so two times T is occurring here, so this is not a isomorphic. These two are not isomorphic. So let's try to directly code this one and understand. So what we'll do is nothing but, let's say, we will try to track the occurrences of characters in a map. So maybe instead of map we can do it in array also. So single dimensional array. So int m1 is one array to like track the occurrences of characters in string s. So what we'll do, new int of 255. So why we are taking 255? It is actually 256 in terms of array because it starts from 0 to 255. So this is like a ASCII characters. Okay, we will convert it. Then int m2 for tracking the t string. Okay, new int of 255 size. Okay, then we'll do one thing. Int n equal to, we'll take the s dot length. Okay, then we'll do one for loop to traverse to the string. Okay, int I equal to 0, I is less than n, and I plus plus, and inside that what we'll do, we'll write one condition. If m1 of s dot char at of I, okay, not equal to m2 of t dot caret of I, then directive will return false. That means that string is not isomorphic. And if it returns true, if these are matching count, then what we'll do, m1 of s dot caret of I equal to I plus 1. So why I plus 1? We'll see. 2 dot t dot caret of I equal to I plus 1 again. So basically initializing this array like positions to 0. So we'll get confused if there is some character for which ASCII value is 0, then it will get confused whether it was occurred or not. So that's why we are doing I plus 1, just to increase the position by one number, right? So otherwise we'll return true. So yes, this is submitted also. And like here, if you see the time complexity, it is nothing but O of n. Why O of n? Because we are iterating only a single for loop. And space complexity, it is O of 1, or like we are having just a constant space for these arrays, right? So yeah, that's it for now. Thank you for watching.